Now, in this video, we want to apply those rules, okay, in evaluating the following limits. And then we'll be doing this by just substitution. That is, when x approaches a certain number, right, even if x is not equal to that number, as it gets closer to that number, we want to see where the function is approaching. So we'll just do that by plugging into each of these, right? Plugging into this one, 4 to this one, and pi, you know, here x is approaching pi into that function, and then we evaluate and see what we get. Good. This is an approach we use generally whenever we want to evaluate the limit of a function. But there are some functions in which when you evaluate them just by substitution, gives you some issues, alright? Okay, such functions I'll be considering them in my next video and not in this one. These ones are just simple examples that will give us a straight result. Great. Anyway, the one that would demand more work, we are going to see it as we come along. So here we have the first question, that the limit of 5x squared plus 4 as x tends to 4. So we want to find the limit of that function as x approaches 2. Okay, great. Let me put it down here. Good. So by substitution, we just plug in this value that x is approaching. We just substitute that in and see what we get. If we have a real number as an output, okay, then that limit exists. Then that real number is the limit of this function. Right. If we, at any point, we have something that is not very nice, then I'm also going to show you, though it's not going to happen here, right? I'm also going to show you what to do, or if you have to do anything about that. Good. Okay, so by substitution, we just plug in 2 in place of x, and then we simplify. That means we're going to have 5. So in place of x, we plug in 2, right? And we just square it, and then we add 4 to that. So you simplify this, you're going to have 2 raised to the power 2, right? That's going to be 4. And then 4 times 5, that's 20. Then we add 4 to the result. So let me just bring it step by step. And then that gives us 24. So that tells us that 24 is the limit of this function as x tends to 2. Alright, good. The next example, good. Let's do the work over here. So as x tends to 4, so say we're just going to substitute 4 in place of x. So that is going to be 2 minus square root of 4. Then we divide that with 4 plus 1, alright? So square root of 4, well, in this case, we're going to consider the principal square root of 4, which is going to be 2, alright? Don't be confused when you say square root of 4 is positive and negative 2. That is wrong. Square root of 4, provided 4 is known and it's positive, is just positive 2, alright? So we plug in 2 in here, we're going to have 2 minus square root of 4, as I said, is 2, and then 4 plus 1, that is 5. Well, we have 0 in the numerator. That tells us that the result is going to be 0, given that the denominator is not equal to 0. Alright, well, here, as x tends to pi, right, we want to evaluate that limit. It contains some trigonometric functions, that is cosine of x. So you need to know what cosine of x is as x tends to pi, right? So let's just do the substitution and see what we get. So we have 2 times, well, cosine pi is negative 1, right? So you observe the trigonometric table, you will see that, right, given the basic angles, like pi, 45 degrees, and so on like that. So sine pi is going to be 0. That is what we get. Okay, good. And then when we do the simplifications, 2 times negative 1 divided by negative 1, you're going to have 2 as a result. So 2 here is the limit of that function as x tends to pi. Alright, great. Okay, thanks for watching. Please subscribe to my channel.